quickly, and then come back to answer questions about what you're interested in for either part, because we're already behind, and I'm not going to be the one that makes us get behind that much further. We'll forget whether it sounds okay. I was part of a NASA-funded professional development workshop to help get across topics in Earth and space sciences that were hard to get, and we chose to do it by talking about how to actually get this evidence together and show how old is your Earth, how old is your universe. And so let me just rip through this pretty quickly. These are some of the astronomy topics. Now, we spent a week on this. The teachers were expected to spend many weeks on it in class, and so this isn't going to be fair at all. I'm not going to be showing you how to do these things, but I'll come back and answer questions as you go. Start off with a little confrontation, is what you see. Not everyone, but sorry. Okay. So the question to ask the class is, where was this picture taken? And for starters, it's amazing how few of the adults, let alone the kids, know anything about geography. But most will go to Florida, and then most will then know something about Cape Kennedy, Cape Canaveral, NASA, something like that. And the answer is, yes, it is Florida. No, it is not Cape Canaveral. That is not the space shuttle. That is a small mock-up of the space shuttle. And if you go from the right point of view, everything looks like you've got the space shuttle in the distance. I don't know what picture I'll use here. But if you go just a step to the side, you can see big differences. So assumptions can be wrong, and that's the problem that astronomers deal with. So try to catch their attention with a conundrum and try to get their point of view of, we need different methods in order to measure distances. Our eyes can be fooled, and in astronomy, everything that we've evolved with in eyesight doesn't work to measure or estimate distances in astronomy. We need different tools. Now, a long time ago, I got an involuntary retch and will automatically throw up the moment someone says, "Oh, parallax, put your thumb in front of your face and start blinking your eyes." And I don't know of anyone who doesn't understand parallax who came away with an understanding of parallax just by putting their thumb in front of their face and blinking their eyes. And what I think is really important about parallax is getting kids to understand how it works and what can be changed in order to estimate distances better. If we were in World War II, we'd pull out rangefinders like they used for tanks in order to measure the distance for ballistics. But nobody knows what an old World War II tank rangefinder is. And so try to pull up some things. In these pictures, which of these objects is closer? So if we've had any lecture on parallax, that ought to be easy, but I find that it challenges a heck of a lot of people as they look through these. This was published in the back of, I think, Sky and Telescope, although maybe Astronomy Magazine, 15, 16 years ago. And it just happens that while trying to take a photo of this comet near Jupiter, these two people in California happened to snap their shutter at exactly the same time and catch this fireball in the sky, and they were located some tens of miles away from each other. And so just wonderful serendipity. You can pull this out, and there are images on the web that are done with the moon and other things that show parallax in action. But when we talk about Tycho getting famous in the beginning for Tycho's supernova and showing that a supernova is a faraway thing or that comets are faraway things, that this image, I think, pulls that off really well. So you can do it for the moon. You can pull things together. This is a much more modern, coordinated campaign to show the parallax, where the moon is in different position with respect to the stars, depending on where on Earth you're taking the picture from. But I find that the previous picture works much better. So showing parallax, showing how parallax works, I don't spend a moment with my thumb in front of my face, blinking my eyes to talk about parallax. Transit of Venus, telling us about how far away the sun is, and then an actual parallax activity done from the inside. This was the Project STAR activity that we borrowed, setting up a baseline, measuring the angle by squinting along the protractor using where it's graded to point towards an object down the hall, and then going back and calculating it out. And so doing parallax, going outside, measuring distances to a cell phone tower, a water tower, some object that's easy to see that you couldn't otherwise measure the distance to. I'm going to run through these even faster then. Once we've got the ideas of measurement, going to the idea of standard candles, which is really a statistical argument. It's an insurance actuarial argument. It really doesn't have much to do with science. You have to convince them that it makes any sense, even though you don't know how big that object is, to say it's the biggest or brightest or whatever, and therefore its size is about. I am big in spectroscopy. As a research astronomer, spectroscopy is my discipline, and so very specifically taking handmade spectroscopes like were created yesterday, and working from there to understand the rest of the things until we get to the expansion of the universe and the concept that leads to the Big Bang. So this is just the quickest snapshot of the type of things we did with them. Now what we did was we put them together and we showed them all this. We spent a week with them. We're giving it to them. We had pre-test, post-test. We established that they knew what we were talking about. They could get it back to us. And then we went to what unfortunately is located in my home state, the state of Kentucky, the Creation Museum. The Creation Museum opened in 2007. It is huge. It has production value. There aren't many museums in the United States that are as sweet and clean and pretty and easy to navigate as the Creation Museum. It is one killer design for a museum. It is beautiful. 720,000 visitors a year. That's my competition. Huh. I could go on with pictures. Usually people are dying to know more about it. What we chose to do was we chose to get this VIP tour. I thought there were two ways. Either I'm going to do it stealthily, I'm going to go in and never admit who I am and pay full price, or I'm going to go in brazenly as, you know, we are astronomers and geologists, and these are middle school teachers, and we want you to prove to us that your museum is worthwhile. And we chose the latter, and they gave us a great VIP tour. Now, they promised us 2 PhDs. In the end, I will give you their story. There was an unexpected scheduling conflict. The person dealing with the schedule messed up. We didn't have our geologists with us. We got talked to by their geologists. We had a couple of astronomers. The astronomer who graduated from the University of Colorado with a PhD just didn't happen to be available to talk to us. It was just an unfortunate snafu in the schedule. I really wanted to ask the astronomer how we can take things like parallax and Cepheid and measure the distances to many tens of thousands of light years in our own galaxy. Skip the Big Bang, skip Hubble expansion, and yet he says the universe is 6,000 years old. I really wanted to ask him that basic, simple fact. Skip all the other little details. Just I can figure out the distances in our own galaxy, many tens of thousands of light years. How can you tell me that the universe is only 6,000 light years old, therefore I should only see to a distance of 6,000 light years? And the important thing here is we didn't do anything special with the teachers. The teachers had gone through the workshop, and then we packed them into a van, and we took them to the museum, and they looked through it, and it is good. It is great. And what the museum keeps saying is God's Word is the key to the past. Now, from my point of view, my eyesight, my ears, I saw great corruption of evidence here, there, and everywhere up until they get to a sticking point, and then they say, well, God says it so. And yet they keep saying they're being scientific. But just when it gets sticky, they say, well, it's in the Bible. And no, you don't take it on faith and call it science. That's not fair. But we didn't bug the teachers about any of this. We got out of the meeting, we talked out of the day, we talked to the teachers, we had other people interview them, so it was anonymous. We asked non-leading questions, very open-ended, so they had a chance to tell us what they felt like about all of this. And they said they liked what they understood, that the universe was very old and that the Creation Museum was not giving a fair presentation. And then we asked them, okay, and what evidence supports that? And all of a sudden it failed. It failed totally. And that's really my take-home message, is that we thought we were doing great. We thought they learned in the workshops. We took them to the Creation Museum. They came out of the Creation Museum, and in the open-ended interviews, they said, oh, the Creation Museum it's not proper, it's not right, it shouldn't be. Of course the universe is billions of years old. Of course it is. And then we asked them, what evidence supports that? And that was really the whole point, and they couldn't do it. And so my take-home message is, gosh, we have so many things that are conflicting in our minds. And, you know, we keep saying that our heads aren't empty vessels to be filled. But try and test and check and recheck. And we thought we were doing great. And when push came to shove, what I really cared about is, tell me why you believe my story. Don't just believe it because I'm a nice guy. Tell me why you believe my story. And their head was full of all sorts of things, not what I wanted it to be full of. And that's my take-home. Thank you, guys. Yeah, Carl.
I wondered if they're all in children. Everything's classified. What edition of the Bible? I'm not sure who said thousands years ago, and then what third of them?
I don't understand, you know, it's not written in the Bible that October, whatever, 4004 BC, in the morning, you know, Bishop Buster's stuff is bogus to me, and yet the fundamentalists believe it as though God told them that that's how it was. I don't get that at all. That doesn't make any sense. That wasn't what our teacher's problem was, but that is what the Genesis people, these people are called Genesis first, were starting this. Oh, and just by the way, they're upping the ante, and my Commonwealth of Kentucky is funding a nearly $1 billion amusement park centered around a full-scale replica of Noah's Ark. That will be coming in like 5 years. Yeah.
I teach stuff about aviation, so, and I get a lot of tips on these ideas. Do you have, I mean, what points did you come up with?
I'm being straight with you from my own biases and my own point of view, but with the teachers, we very much just wanted them to see evidence for why the universe was that old. And if the universe was that old, then we ought to be able to understand that an old universe is a big universe, and we ought to be able to establish that Bishop Usher was wrong. But we didn't do anything to fight against creationism per se. All we tried to do was, this is the evidence for what we're saying. And my thought is, if I could establish how big the universe was, then you'd get a feeling for how old the universe was, although Jason Lyle, the PhD from Colorado, can compete with us, can't do that. But if I could just establish how big it is, then you can get a feeling for how old it is, however limited our minds are, and then there'd be room for doing things like evolution. We didn't touch biological evolution. We only did the age of the Earth and the age of the universe. We stayed away from most of the hot point topics, very much on purpose. In other words, we didn't address your question. All we were thinking. Start at the end.
Another, I tell you, so we're trying to speed up life. Well, obviously, the universe is 6,000 years old, so that means the speed of light must be much faster, far away from us, such that the light doesn't have to come. What do you think?
That it's a changing speed of light. That the processes we see when we see in things on an outer arm of the galaxy are just the same, and at that point it becomes an unlikely that somehow everything is managing to stay the same, so that Newton's version of Kepler's law works just as well even with different speeds of light. So everything is changing in lockstep, and that's a great burden on you to show why all those coincidences stay true, because it's just your book. Yeah. There's a chat says, do you use Sagan's baloney detection? No. Well, I love Carl Sagan, and I think that by the time he wrote Demon Haunted World, he was just a little bit too harsh for my audience in Kentucky. And he's speaking to me, but he's preaching to the choir, and it's fine with me. But when he gets to the Demon Haunted World, he's just a little bit towards self-righteous. He's a very fair-minded person, but it's on the edge by that point. And I find that I just turn people off. For instance, I don't bother talking about astrology either, because I don't think I'm going to change people's minds. I just try to go with evidence.
Last question here. Yeah, sorry.
I will hand it over. So, yes.
People always want to reinforce what they think the reality is. For years, I've been talking about a few things that deception. And quantitative is showing this, and that this happens. They know all the way on. Then they'll say, well, if the definition of the zodiac sign is that a constellation is to be something, it has to be zodiac, it has to be all the way down. And then I give them a chart, okay, find how many constellations are hitting each other. You find 30. And that causes the problem. And I said, okay, because the percentage, that will be changed, understand that. Then what we do, is you're looking at your case for the zodiac sign. And there's always at least one or two students here that get really, really upset. One person said this put her astrological tattoo on the back of her neck. Now, because of the law was the answer. Okay, and the thing is, it just has such an inward belief in it that they have a hard time accepting something other than what they just become belief. It's the same thing with the creationist person. They do the main situation. As soon as it was on the internet, everybody did it. Oh, yeah.
I got the message. I got in earlier, but I had to. Long story. I know how to do it. Maybe I thought I could. There we go. Okay. Just need first names even. Okay. Okay, so we should. There's one more button I need to push.
Do not do that.
Do not do that. Okay.
It's loading something now.
Now allow. Okay.
Alan, are you there?
Okay. Okay. So now.
Check. Alan, are you home?
Okay. Wow, this is cool. I've never done this before, so it's cool. Okay, my name is Rob Sparks, and I work at the National Optical Astronomy Observatory now. I wear more than one hat. And one of the hats I wear is, it's actually trying to start to advance on me by itself here. One of the hats I wear is I work with Sonoma State University as one of the NASA Educator Ambassadors. The formal title is Astrophysics Educator Ambassador. One of the worst titles I've ever come up with in NASA, in my opinion. But and we work with Swift satellite, the Fermi satellite, and the
Going to get rid of that.
GLAST. The Swift satellite and the Fermi satellite are our two main ones.
Oh, what did I do?
Yeah,
Sorry.
that did that last time too. When you
Hit that negative.
The negative.
Yeah.
So I'm sort of here more in my Sonoma State role than in my NOAO role today. Tomorrow I'll be doing another talk in my NOAO role. So keep track of who I am here. So today I'm going to talk a little about the Global Telescope Network and how it works with Skynet. Where is the mic? Yeah, where's this? Oh, this is the mic. Okay. I didn't realize it was. I did just unhook it. I think this was just like this for the. Oh, so I can unhook it. Okay, so I can unhook it and walk around. Okay. Is that better? So anyway, the Global Telescope Network was set up to allow people to contribute data to support NASA's high-energy astrophysics missions, specifically SWIFT, XMM Newton, and the Fermi telescope, which was launched in 2007. So the idea is we have ground-based observations in the visible spectrum of the objects these guys were observing in other spectrums, specifically mostly X-rays and gamma rays, things we can't observe from the ground. So it's a network of ground-based telescopes, which the Yerkes 41 inches. Is it online now, Vivian? Okay, cool. Yeah, I see it's listed on the Skynet website, so it has the specs on there. So didn't see any data from it yet. So I haven't looked too. I didn't look closely enough to find it. Just a very quick look. But support Fermi, Swift, XMM Newton. And my wants to keep advancing on me. There's several different partners. The data once you take data, it goes in the AAVSO database. Hands-on Universe was getting involved with it. Elk Creek, which is Mike Fort, those of you know him, he's done a lot of work with this as well. Cal Academy of Sciences, Wyoming, and they're looking at, Veritas is looking at getting involved with it, but I don't think they're actually on board yet. So there's another group that they're looking to get involved with. So the types of objects they're looking at studying are primarily active galaxies, active galactic nuclei, the ones with massive black holes at the center, which give off jets and copious amounts of X-rays and gamma rays. We can look at gamma ray bursts, obviously, which is what Vivian did last night. Just got a gamma ray burst. We want to combine the data with what we get from the satellites there as well. So that's sort of the idea of the whole network. Active galaxies, I said, they're bright galaxies, unusually bright nuclei, thought to have massive black holes at the center. I don't know why my timing is going automatic here on me trying to do that. Sometimes they have jets coming out of them from the black holes. They frequently have very bright emission lines. And these guys can vary visibly over the course of a night. So you can actually get a couple tenths of magnitude variation over the course of a night in some of these. I thought we were doing some observations with one of the telescopes one time, and we literally took, an image of one of these galaxies and compared to a reference, and it's like, whoa, yeah, that changed a lot since last time we imaged it. Didn't even need to do photometry, just look at it and visibly see that there's definite variation. Then, of course, you go back and get the actual change in brightness. Another fun object is on the observing list of the Global Telescope Network are these things called polars, magnetic cataclysmic variable stars. These are white dwarfs. They have unusually strong magnetic fields. And they orbit a normal star, which draws matter off. And when the matter accumulates on the surface, you can get explosive X-ray flares, which are great objects to observe as well. And again, these things can go off, and they can change brightness very quickly, even over the course of an evening when one of them goes off. And there's about 20 of these objects on the list that the Global Telescope Network would like to monitor. And, of course, gamma-ray bursts. These things are busy. How many of you guys know what gamma-ray bursts are? I expect most of you would. We don't know the story of gamma-ray bursts here? Okay. Gamma-ray bursts are these really cool things. They are these incredible bursts of energy that give off, in a matter of seconds, the amount of energy the sun does in its entire lifetime. They're these massive explosions. We didn't know what they were for a long time. We finally start getting to the point where we can see their afterglows and measure their distances by getting redshift. And found out these guys have an average redshift of about 2.2, I want to say, if I remember correctly, a little over 2, which corresponds to distance of 8 billion years or so, 8 billion light years away. They're very distant, very bright. We see them clear across the universe. They usually last a few seconds. A long one might last a minute or two. Them at first because they fade very quickly. So Swift sends down the alert, says that the gamma ray burst went off, gives you the coordinates, and we want ground-based telescopes to go there quickly within minutes to try and catch the afterglow. The afterglows can fade within minutes. Invisible, so you need to get there right away. A good afterglow might stay around for hours to days, but probably might get one a couple months later. But there's a target list on the web, and I'll go to that website right here so you can see what the target list looks like. Actually, I think I have it on the next slide, too. There's a list of about 3 objects they want to monitor. They're mostly AGN and polars. Here's a little portion of the list. I'll actually go on the web and go to that right now. Can I leave this one? So I'll just go to a different window. There's a Global Telescope website, and if you click on the object catalog, it sort of gives you the objects they'd like to observe. There's the galactic coordinates of all the objects. The blue ones are the AGNs, and the red ones are polars. And if you come down here, you can see all the different objects. They give you the name, the object number in the program, the name, designation. Sometimes there's alternative designations, the magnitude, the RA index, and there's, the range of RA index is different negatives. We get northern and southern hemisphere objects, and a good distribution around the right ascension things. Pretty much from what we're seeing around the world, always find at least a couple of these objects that you can try and image at one time. So that's sort of your list of objects. And the telescopes in Skynet, typically, the Skynet telescopes I use typically are the 14 to 16 inch range. Yerkes is a 41 inch, which is sort of outside the range. I think there's a newer 30 inch telescope in there too. But the telescopes I use most of the time, the prompt telescopes in Chile, are in the 14 to 16 inch range. So you can get down to magnitude 16 with a couple minute exposure. Yeah. Do you do what? Yeah, no, I think this is to talk about extended sources rather than point sources. Point source you probably could get dimmer than that. And these scopes are limited to fairly short exposures because of the tracking. Yes, wow. Yeah, you can get these are single images, obviously. With those, wow. It is really good. 20 seconds. Anyway, you can easily get down to the magnitudes we need to with these telescopes for the objects in the list. So they're typically selected. They're typically small. They have science they can track the objects for a couple minutes. They have scientific filters on them, the UV-VI filters. Some have the phone filters. Some have some narrowband filters like oxygen or sulfur. So there's a variety of filters on these scopes. And I'll show you on the website, there's a list where you can find out what scopes have on them. Here's a picture of the scope at Sonoma State University. That's a 14-inch, if I remember correctly. They call that telescope, originally the Fermi X-ray Space Telescope was called GLAST, the Gamma Ray Large Area Space Telescope. And they renamed that to Fermi, and the acronym they came up with was GORT, the GLAST Optical Robotic Telescope. Bonus point for anyone who knows GORT. As a couple people do. From a very famous science fiction movie, they stood still. So, and then they renamed it Fermi when it launched, but they still call it GORT. So GORT, yeah, you can't not call it GORT after going to all that trouble to come up with that acronym. So we're going to actually look at how to take some data with this. And, I have one password and username here, which I can actually log on to and try submitting an observation request. Now, it's sort of a group password. You can have more than one person log on to it at one time with it. I don't know what the maximum number is, but I've never had it say you can't have this many people on. So anyone who likes to try logging on can. Skynet.unc.edu is the website we use for the portal. What? Okay, thank you. And you'll find the website looks something like this. And the username we use for the Sonoma State University one is FSU2. And then the password is Whitney, W-A-I. Do you want to write down the password and username too, Vivian? W-H-I-T-N-E-Y. Just like the name Whitney. So I'm actually going to get out of here now and start going into doing it live myself up here. Where'd my browser go again? There we go. Oh, before I actually go into it, though, I want to show you this, the button at the top here, Our Scopes. If you click on the Our Scopes button, that'll show you the latitude, longitude, as well as some information about each of the scopes. Yep. This is a Q-based system, yeah. Yeah. This is Q, which for students is actually pretty nice because you can actually set up observations during the day, and they don't have to be there at night. They can go home and you can sleep and then come back and get your data when it's taken. But there's a nice little list here that shows you all the different telescopes that they have. Typically for the prompt telescopes, field of view 10 to 20 arc minutes or so. You can see they all have different combinations of filters in them. So that'll tell you what scope you might be using, obviously depending on what filters you want to do. I'm going to type in my username and password here. I can't type with one hand.
So that your key actually doesn't exist anymore?
Yeah, actually, your key option.
So there's a second way to get in? Hey, good reason. So this is sort of your greeting screen here. And if you click the observation manager, that's where most of the action takes place up here. And if you're under the Your Keys one, it'll look pretty much exactly the same, except of course you'll see different user and group name with different observations that have been taken. So you'll get a different list there. So these are observations. You can see this is not a very heavily used account because if you go over here to the time, the observation taken, the last observation taken, this account was in May. This account is definitely not oversubscribed, to say the least, since I haven't taken an observation there in a couple months. Now, it is one account, so if I take an observation, Tom and Rich and Kevin take observations, they'll all show up under here. So as you can see, a lot of people give their observations names. So they say like Capella, then I assume this is the person's last name who took it, or CG1, and that may be the person's name who took it or something. I don't know who that is. But I might just use my initials. I might just put like RTS or something with the observation name so I can find my observations easily again. But we probably want to put your initials or some identifying feature there to help you find your observations once you've taken them. So to actually add an observation, there's a nice little nice little button up here. You can add observation and come up with a nice screen right here where it asks you for information. You've probably seen a lot of this information before. If you know the right ascension and declination of your object, you can enter it directly. If not, you can actually look it up by the name. So if someone has an object that they think might be visible nicely in the night sky, especially from Chile, since most of the scopes are down south that you could look at, they have a request. I'll get to that in a minute. Once you enter all this data here, what object you want to look at in your filters, it gives you a list of telescopes that meet the criteria. We'll be able to take that observation. If I want to use the UVB filters, it'll give me a list of telescopes on the next page that have those filters in them. Whereas if I click RGB, it might give me a different scope. A different scope might have RGB filters in them. No, remember, 10 to 20 arc minutes diameter here. And that's another thing. When I do this workshop with regular teachers, they don't think about the size of the objects, and everyone wants to do the Andromeda Galaxy, which is 3 degrees across. You get like 10 arc minutes of it, and it's not the most impressive sight in the world. The tarantula, what's that? That's 30 Doradus? I'm going to see if it takes 30 Doradus. I can't remember how to spell it for sure. Hey, it took it. Good. We got 30 Doradus in there, which is the Tarantula Nebula. And once I type in here, it actually looks up the right ascension and declination for me. So this actually filled that stuff in for us. And that should be, is that up tonight down there? I don't know exactly. I've never actually been in the Southern Hemisphere. So I say something in Sagittarius because we know that's going to be up nicely tonight for them. Something near the galactic center. You don't have their favorite Messier in Sagittarius? M8? The jewel box? What's that one? Does it have a Messier object or NGC number? Do you know? Okay. Let's just go for M8 because it's nice and colorful. Okay. So there's a bunch of options we can put down here now. This is this is mainly a test account. Priority 6, we really can't change that. They give us low priority, or actually we can go up to low. I guess we can get lower priority than priority 7. But that's if a scientist wants to alpha gamma ray burst or something, they're going to bump our observation down. So we're pretty low priority. Now, even with that low priority, I've had times that I've literally put in an observation, come back 20 minutes later and it's been done. So if there's actually a clear sky and not much they're looking at the time, you can get observations the same evening. On the other hand, I've put in observations that have also taken a week or so to come back if the weather's been bad or something. So it is a queue-based observing system, so you want to make sure you do this in advance so you have the data when you need it, because it might take a little while, but sometimes if you're lucky, you might even get back like 15, 20 minutes later, so I've had some very good luck with that as well. Yeah. Like I said, I've had lots of times I've done it the same night, within a half hour pretty easily. That's not uncommon, but I've even had that too. It's really been a minute or two later to come back. Just pretty much almost literally enough time to take the exposures, and then been in there already. Yes. Sure.
Most of the time, the telescope is set at the start and taking observations until you're at astronomical.
Yeah.
So if you take this minus 18 to like minus 12 or minus 15, your observation will slip in
Good tip. I was going to get to that one. I was going to mention that. And that's okay. I've done that one too. I discovered that one too. Depending on the object, if it's a bright object you don't need total darkness for, changing this to negative 12 or something is a good trick to sneak your object in either at the beginning or end of the night. And sometimes you might be able to sneak an object, that's lower in the sky in the evening too. Especially if you think about, sun's negative 12, you have an object in the eastern part of the sky. The eastern part of the sky might be dark enough, whereas the western part wouldn't at that time. So think about that even. I even think about, mapping out my object. Okay, change this, do an eastern object. There's all kinds of fun tricks you can play with there as well. The air mass, obviously that's air mass of 3. Air mass, if you're looking straight up, you look at least after, that's 1. As you go down, I think 3 is 30 degrees, is it, or is it 20? I forget. But it basically says you won't look too close to the horizon. And I usually just leave that as the default. I think it's 30 degrees, so I'm not 100%. Or 30 degrees too. It must be 20 degrees. Yeah. If you want to look through less air mass, set this to 2 or 1. It'll take it when it's close to the sky. Of course, you set it at 1, your objects better go right by the zenith. Otherwise, it'll never take the image. So I usually leave that by itself there. You can change the time you want to start. If you want to make sure you go and take your observation tonight, but take it tomorrow night, you can set the start time. Usually, by default, this is set now. So most time, that's fine. And of course, we get to select our filters. So we can select any combination you want, but if you check all those filters, no single telescope has all those filters. So therefore, you'd probably get no telescope that would be able to do your observation. So you have to think about what filters would be good. Well, this is a nebula. What filters would be good for a nebula, you think? RGB. If you want to do a nice color image, you probably want a nice RGB. So I'm just going to click RGB here for fun. And then I'm going to click Next here, since I got everything set on this page. Next page is now like that, comes up and tells me what scope I can do it from. And I can select either any one of those 3 scopes or all of those 3 scopes. I'm just betting that the weather here looks kind of dicey tonight. What do you think?
Supposed to get good.
Supposed to get good? Okay. Well, obviously, the more scopes you check, the better chances you are of getting the image. So I'm just going to check them all and see which one comes back tonight. So I'm just going to check them all. We'll take it on the first one available if the weather conditions are met.
You know what, I think that we haven't, one of the things we haven't done with the Viewpoint is done a focus table for when the telescope is low and perfect, and focus when it's high. So if you take that change before you want it, it'll probably be
How to focus? Okay. Yeah. Well, we can take that one off then. So and besides, M41, M8 will be a lot higher on these telescopes than Shelley than it is here too. It's going to be a lot less air mass as well. So it'll be a lot better view down there. Now, there's another neat thing here. This is thing. I'm glad we chose this one because I was going to mention this to you. This does have intelligence built into it. If you point it at a bright object like a bright star, it will actually limit your exposure time. So for this one, the maximum exposure it's going to let me do is 40 seconds because there's a bright star in the field. Now, if I have an object where there's not a bright star in the field, I might be able to go up to 80 or 120 seconds, depending on the telescope. Most telescopes, it's between 80 and 120 seconds is the maximum exposure. But this one, because of that, I'm going to do 40 because that's the max it'll let me do. Let's see what happens. It also lets you take multiple exposures. Like I said, so if you want to stack things, I can take more than one exposure through each filter. So I can take 2 or 3 exposures through each filter as well. I can set that up. So how many filters do you want to take? Just start with 1? Let's just start with 1 through each filter and see what happens tonight. So it also lets you do some ordering stuff here. I can do red. I can do all 3 exposures through red, then all 3 blue, or all 3 green, or I can alternate them. Only doing 1 exposure, that's sort of a moot point, right? But I can actually do either sequential or interweave them down there. And I also can actually repeat those exposures. I want to do more than 1 observation if I'm trying to do like an asteroid or something that might change, for instance, or a variable star. I can actually repeat these exposures multiple times over the course of a night. So I can say repeat these every 30 minutes throughout the night if you can, or something like that, and see if there's any changes. So I'm just going to do this with, keep it simple for the first one. Yes? I believe I can go back, yes. They're back. There's the back button, okay. Maybe I can go back. It's just thinking.
What I was going to say is that one thing I noticed with the front telescope is that sometimes the very first vision isn't the telescope not subtle. So on that first filter, I would put it in 2. So it gives a chance. Because I think they're like so set for like those DRG stats that they start taking that image as soon as the telescope says it's blue.
So vibration damping time a little bit there. Okay. Okay. Well,
And also, I'm just jumping in here because I'm not going to review this during my session. On that, look, if you choose multiple observations, realize that those
I've tried that too. It's not. Yeah. Neither one wants to go right now. Ah, okay. Or you could just set the start time on the previous one too. So, yeah. The one other thing I'll remind you is this, this is UTC, so make sure to convert your time zones correctly as well. So I believe they still go in UTC, so convert. Yeah, I'm not sure why it's not wanting to go back here. Maybe we are overloading it now. That's okay. Let's see if it's okay. For some reason, the site just seems to be not wanting to do much right now. Not even taking the confirmation. Okay, how many? Just like how many people are on it right now? That's not only 2. That should be fine. Oh, 4 or 5, yeah. That should be fine. I see someone pop in on the thing up there. It says we're on 2 online. Yeah. The little chat thing. Yeah. Anyway, that's the basic idea here. I always plan for this, and just in case, I always have the next one on the a screenshot of when I did it before. So there you get the observation menu. This is the screen we were trying to get to confirm. If it's been there, you end up getting it in the queue. And hopefully, when it shows up, it'll say it's active. That means it will be taking this next available opportunity. And just to give you an idea, here's one of my friends did this one, isn't it? Well, it shows up really trouble on the screen. The M104 image on my computer screen shows up really great. You can see the disk with displays and everything, but on the projector it just doesn't show up well. This is when people actually on the online session probably get a better view than people in the room for a change. I think it's a nice image of that. Again, each telescope has its own maximum tracking time based on its mount. Yeah. So some of them just don't track as well, so they limit the exposure time to a couple minutes. I don't know. Do you know what your maximum exposure time is going to be on the 41-inch? 3 minutes. Yeah. Oh, the tracking goes down after 15 minutes? Yeah. There's periodic errors, unless you set a separate tracking scope or tracking CCD or something. You're going to get periodic error. Yeah, an auto-guider. That's the word I. Yeah. Yeah. So you can request multiple. You can request multiple 2 or 3 minute images and stack them. Yeah. Yes, you can do that. So that's why I said the number of exposures. Click 2, 3, 4, 5, or 6 instead of the 1 I put in. You'll get the multiple images you can use to then go ahead and stack them. Like I said, with Sonoma State, we can use theirs as well. So you can also, people in this room can split up with Sonoma State as well and do something with that as that counts. This presentation, I can definitely get it there if someone shows me where to put it. So yeah. Okay, yeah, I can definitely give it to Alan and he can put it in there, yeah. So I'm definitely okay with putting it in the archive. I wouldn't mind doing that. Just so you know, on the gtn.nome.edu website, there's all kinds of student activities and stuff like that. There's tutorials on how they want you to do the photometric reductions of the data and that sort of thing, and how to submit it to the VSO. They have this nice activity booklet online. It's think that's still the right website. I didn't check it though, so they might have, they do move it around. They have moved the website around a little bit. I think that's still the right address. But if you just go to the website, you'll find the student guides and that sort of thing. Now my computer doesn't want to go at all. There we go. Of course, I just always leave this slide on there. There's all kinds of digital imaging processing. I suppose most of you will probably be using Salsa-J or the HOU software. But there's all kinds of different image processing software I've used all over the past. Some of which is free, and of course some of which is paid. And of course I use HOU stuff myself as well. So there's just a whole list of other some of you might have heard of some of these guys. Iris I really like, except it's only available for Windows. If you ever use that one, it's a free one too, but it's only available for Windows is my problem, because I switched to Mac. So. 8 for Windows you have to pay for. Mac and DSL you have to pay for. CCD stuff is pay. Mira I believe is paid, but it's actually, if I remember correctly, one of the more affordable ones. Iris is free. SIP is kind of an interesting one because with schools, a lot of schools don't let you install. A lot of schools can be very problematic with installing software on your computers. And the student imaging processor is actually a Java-based one, so it's browser-based. So some schools that don't have any, that the teachers have a very difficult time installing software on their computers, that can be a reasonable alternative if they don't let you install the HOU software or something. What? Excuse me? Yeah. Yeah. The UNC one's costly? Yeah, yeah, like the and Micro Observatory images it has its strengths too, but that's another free one from the Harvard Smithsonian Micro Observatory if you've ever used that system. It's a free robotic telescope system, but it only lets you take images of certain objects, but it's also very nice for a beginner system in my opinion. But when I do teacher workshops, I frequently will say, begin with the Micro Observatory, then graduate to Skynet. It's a good way to get your feet wet. And they have fewer options with the telescope, so you have you don't have all those filters which not everyone knows what they mean and that sort of thing. So it's a nice way to get your feet wet in the beginning part of imaging. So anyway, Vivian will be doing a lot more with Skynet, and I'm sure that tomorrow we will hopefully have some images to play with. Yes, Alan?
So you're up for questions now?
Sure, I'm up for questions.
Well, first question is, well, and this is also by way of a reminder that the radio talk system is recording.
Mm-hmm.
And my plan is to post them. There's going to be a little so those passwords, do you want those, those show up on the internet, or should we delete them?
Probably not quite that extreme, yeah.
Yeah, so that's something
okay.
to be careful.
Yeah.
And the other thing is that we have...
But I don't think it might be security through obscurity. No, most people who see it are going to be people that are in this group anyway.
Not that many people are going to bother. Yeah. Speaking of which, there's a few people online. Harlan DeVore.
Yes. Hi, Harlan.
Ken Grant.
Mm-hmm.
John Colina, I think, is watching but not listening. So if they have anything, yeah, they'll chat.
Okay.
If you have any questions on
Hi, Ken.
Either chat or, you know what, I'm going to do, I muted them all. I'm sorry. I'm going to...
The conference has been unmuted. The conference has been unmuted.
As I say, knowing Harlan, that's... No. Kidding, Harlan.
Hi, Robert. How are you?
Hello, anyone?
Yes. Robert, can you hear me?
Yes, I can. Who is this?
Harlan.
Hi, Harlan.
And this is Ken.
Hey, Ken.
Hey.
Any questions?
No, this is a really good presentation, man. Thank you.
Yes,
okay,
thank you.
Okay. Well, if you get any good data, let me know.
Sir, will do.
Okay. And of course, I said the whole point of this is we'd like to have the people actually look at some of the objects on that list and submit data to the AVSO to for the AGNs and the polars. That's sort of the goal of what's known with state's involvement in this is. Vivian? SSSIG, I don't know that one off the top of my head. Okay. Okay, we can look at SSSIG later. Any other questions? Yes, Carl.
So, how many images does Skynet take?
Good question. If you go to the Skynet website, fatal maximum execution time 30 seconds. I guess my observation probably didn't go in there. But if you go over here to the total image count, image count button disabled until they can be run faster. So they used to have this image count feature where you could actually see how many were taken at one time. It looks like that feature has been disabled. But they'll take hundreds per evening on a good clear night. So yeah, it's a lot of images, yes. And of course, if you look at the observation manager, there's also the place where you can go in here and you can actually download the starks and flat frames to do your calibration stuff too. So there's ways to download the calibration frames as well.
Those stay in archive?
Yeah, they stay on archive, yeah. I've found them in archive before. I can't remember where, but I've always found them in archive when I need them. It's one of those things it's one of those things, I'm a lousy teacher sometimes because I know how to do things, but I don't know how to do things. Or I can't tell you how to do things, so I just do it. Yep, there we go. There they are. There's the webcam. That's kind of cool. Mm-hmm. Oh, cool. Right here, this one. Let's see. I thought last night I had this one working. Oh, telescope activity plots. That's what I used earlier today. And if the data comes through, this shows you the last 48 hours which scopes have been active. So this scope in Italy did some imaging, and one of the prompt scopes, at least, the Gore scope did some imaging overnight, and so you can actually see what was up last night. Prompt didn't look like prompt 3 was up last night doing some imaging. So you can see that it did some imaging, but it really wasn't that active. So if you submitted data at the right time, you might have gotten some images back fairly quickly. You want to see the 41 inch, don't you? There's the Yerkes. Yep, there's the Yerkes 41. There's your data from. So you can see it was active last night. That's your. So if you're curious, this doesn't tell you the image counts, but at least gives you an idea of what the activity was. So as you can see, at least last night, there were some telescopes that had some pretty good trick if you planned it right. So these, I don't look at these often enough to have when the crowd's up, but I'd imagine it might. Yeah, I'm taking questions now. So when we're done with questions, we can think about the next activity, which. Yeah. Yeah, that's not my department, but Vivian could probably give you more information about that. Let's do some astronomy.
Thank you. Please stand by.